Okay, this video is about the binomial theorem. Your purpose is to understand calculus, which contains two major concepts, which are differentiation and integration. Before that, we have to know about the concept of limit. But before we the concept of limit is, actually contains the number e. But before we go through this kind of concepts, we have to know about the binomial theorem for us to understand some basic concept in differentiation. So what is binomial theorem? Let's say we have a simple expression here, x plus 1 to power 2. So if we want to expand it, what should we do? We can make use of the basic identities. Becomes x squared plus 2x 1 plus 1 squared, right? Okay, but what if here is not power 2 but power 3? What can we do? We can just do it one by one. That means we first expand up to power 2, expand the first one, and here we do the rainbow. So it becomes x to power 3 plus x plus 2x squared plus 2x plus x. Sorry, here should be x squared plus 1. So I will get x to power 3 plus 3x squared plus 3x plus 1. Okay, not that difficult, but already a bit complicated than part 2. And you can expect the next question is, what if we want to expand x plus 1 to power 4? So we have to, if you want to do it in this way, that means in order to expand up to power 4, we have to expand up to power 3 first. So what if we want to expand x plus 1 to power 10? That means we have to maybe expand x plus 1 to power 9 first. That means again we have to expand x plus 1 to power 8 first. So many steps to do. Is there any systematic way to find the final result for any power? Actually, yes. And that's the meaning of, or that's the purpose of binomial theorem. It is about to expand x plus y to power n. We have a formula for this one. And this formula actually involves NCR. So let's recall what's the meaning of NCR. Actually, it is to the number of combinations to choose R objects from n objects. Okay. First, I write down n factors separately. X plus y times x plus y times x plus y blah 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 times x plus y times x plus y. So here we have totally n factors. To expand it, it means that we have to choose one term out of two terms in each factor. Let's say for the first factor we have x and y, two terms, and we choose one only. Let's say we choose x. And for the second term we also choose x, for example. And the third term we choose x, and all the terms we choose x. I mean all the factors we choose x. And what we need to do is to multiply them together. So we will get x to power n for this way to choose the terms. So now you have to think about how many combinations are there. Here it's obvious that only one combination for x to power n, because there's only one way to choose n x out of n factors, right? So we can see and try another example. Now we also choose one term out of two terms for each factor, but now the number of x is not n, but n minus 1. That means let's say for the first n minus 1 factors we choose x, but for the last factor we choose y. So here we have n minus 1 x and 1 y. Okay, now we have to multiply them all together. We will get x to power n minus 1 times y. Okay, but here how many combinations are there? Is there only one combination to choose n minus 1 x and 1 y among these n factors? Actually no, because we can have another combination, like we choose y from the second last factor and x from the last factor. So here we will still get x to power n minus 1 times y, but here is another combination. And the third combination or third situation, maybe we choose y from the third last factors and we choose x out of the other factors. In this situation we also get x to power n minus 1 times y. So how to find out the number of combinations here? We can make use of NCR. Actually we are choosing one factor for y out of n factors. Can you get it? We choose one factor for the y out of n factors. So we can write down, we choose one factor out of n factors for the y and the remaining for the x. That's how we number of ways that how we get the y, or how we get x to power n minus 1 times y. So go back to x to power n. Actually we are choosing 0 factor for the y out of n factors. So it is NC0. Okay, now keep going. The other situation is we choose 2 vectors for the y and n minus 2 vectors for the x. So the product will be x to power n minus 2 times y squared. And how many combinations are there? That means 2y and n minus 2x. So again, make use of NCR. We choose 2 vectors for the y and n minus 2 vector for the x out of totally n vectors. So here's NC2. So you see that if here we have y to power 3, then here must be NC3. If here is y to power, let's say 6, then the power of x is n minus 6. And here must be NC6. So if we have y to power r times x to power n minus r, that means we choose r vectors for the y out of n vectors. So here must be NCR. So the final term will be y to power n and no x. That means we choose n vectors out of n vectors for the y. So it is how we expand x plus y to power n, and we call it the binomial theorem or binomial expansion. Okay, let's do 1 or 2 examples. Question 1, expand x minus 2 to power 4. So the first term is here n is 4. So the number here will not change, always 4. So for the first term, 4 is 0, x to power 4, including the sign here, minus 2 to power 0. Okay? Plus 4c1 x to the power 3 minus 2 to the power 1. You see the power of x is decreasing, but the power of minus 2 is increasing. And 4c2 x to the power 2 minus 2 to the power 2 plus 4c3 x to the power 1 minus 2 to the power 3 plus 4c4 x to the power 0 minus 2 to the power 4, and finish. And simple calculation, x to the power 4, 0 is 4 times not equal. 4 times minus 2 is minus 8, and 4c2 is 6 times 4, 24, and 4 times minus 8, minus 32, and minus 16. That's it. Okay? Now you can do this one on your own. Okay? And you can check out the answer from this website.